Good evening, everyone. Welcome to O-Level Physics lesson. Today we're doing physics revision on 2013 paper 2. Okay, today is Tuesday, 18th of October. My name is Mr. Chu. All right, let's begin. Okay, let's start. Okay, we'll do very quickly most of the calculation question, description question or conceptual question. Okay, descriptive question we will not go through unless you want me to go through. Okay, so in the speed time graph, can you quickly tell me how do you find the acceleration? Okay, quickly tell me how do you find the acceleration in a speed time graph? Quickly, okay, well done, Yuting. Pei Kuan, are you there? Okay, so we'll not wait for Pei Kuan for now. Let's continue. Okay, so can you explain how the acceleration changed from A to D? Okay, quickly tell me at A to C what happened, and then C to D what happened. Quickly. Okay, Yuting, there's a few things I want you to learn from this. When your acceleration is going, can you see here the gradient is positive, right? You just say that the acceleration is positive. It means that the speed is increasing. Okay, I try not to use the word deceleration because it can be confusing. Okay, so can you see from here A to C, right? You can say that the acceleration is positive and decreasing. You understand what's happening here? Positive means that the speed is still increasing. Can you see the speed is increasing? Okay, so the acceleration, the gradient is positive, the acceleration is positive, but the acceleration is decreasing. Okay, and then from C to D, you need to say that the acceleration is negative. Negative means that the speed is going down. So the acceleration is negative and constant. Okay, so you think if you can add in the word positive and negative in your description, it will be perfect. But you understand perfectly well what is the meaning of positive and negative acceleration? Okay, very good. Okay, part C is explain in terms of the force acting why the acceleration changes point A, why the acceleration changes between point A and point B. Okay, so basically mentioning A to B, the acceleration is decreasing. Okay, use force to explain why. Pei Kuan, are you there? Pei Kuan? You join already but never say a single thing. Okay, anybody need help? Okay, part C, wow, 3 mark question, very long. So what's happening at part C? Okay, so as the stone gain, yeah, as the speed of the stone increases, what happened? The air resistance acting on the stone increases. All right. Then what do you say next? So the net, so the resultant force acting on the stone will decrease. So using Newton's second law of motion, F equal to ma. As the resultant force decreases, the acceleration will decrease. Is that clear? Hello, Yiting and Beiguan. Can you give me some answer? Hello, hello. Yiting and Beiguan, are you there? Hey, so little people here, it should be faster and not slower. It should be faster, not slower. Okay, let's not wait for all of you already. Let's continue. Okay, so based on this graph here, okay, explain how this graph shows that the stone did not reach terminal velocity. Hello, hello. Okay, Yuting, look at this graph. Why did the stone not reach terminal velocity? Okay, very good. So can you see as the speed of the stone increases, it did not reach a constant speed. Okay, so it did not reach a constant speed and therefore it did not reach terminal velocity. Then it hit the water. Is that clear? Okay, very good. Bei Kwan, are you there? Hello, Bei Kwan, are you there? So why are you not participating? Okay, I will not go through this question now. You're supposed to draw the vector diagram for this. Do you all need any help regarding vector diagram? Okay, so I will just skip this question for now, because you need to draw a vector diagram. Okay, let's do this question. Okay, okay, before I will not go through this question, but let me just explain what's the meaning of principle of conservation of energy. Okay, principle of conservation of energy means, okay, means that no energy is created or destroyed. Okay, so energy is only converted from one form to another. Okay, so there is no creation or destruction of energy. Okay, so from here, okay, you can see that at first there is kinetic energy, then convert to sound energy and so on. Okay, so there are energy. So in this description, you need to describe how energy is converted from one form to the other. Is that clear? Okay, so let's continue. Okay, start doing part B, 1 and 2. Okay, y'all may begin. Okay, well done, Yuting. Bei Kwan, how about you? What's your answer? Incorrect, yeah. Energy is in the unit of joule, not Newton. Okay, very good. Okay, both of you understand this question. Very good. Let me just give you the formula. PE equal to mgh. And then you just sub in everything inside, you should get 7.2 joule. Okay, now all of you do part 2. Okay, Yuting, well done. Okay, Yuting, you're asking me a question about at the highest point, there's no kinetic energy. Okay, that is true if you are moving up and down. Okay, but this ball is moving from left to right. It's just like if there's not going up, right, the ball is rolling from left to right. So there is some speed along the way. So even at the top here, there's no the speed is not going, the ball is not going up or down, but the ball is still moving to the right. So as it's still moving to the right, there is some kinetic energy. Okay, Bei Kwan, well done. Okay, so for part B, you just need to add them together. Okay, KE plus PE. And then therefore you get the answer 9.7 joule. Okay, Yuting, you understand now? Okay, very good. Okay, at least you all learned something today. Well done. Okay, let's look at this question. I will not go through between these unless you all want me to help. Okay, I'll not go through this unless you want me to help. Okay, explain the feature of the heat sink that allow thermal energy to be transferred easily away. Okay, so you need to explain a few things. Okay, so let me just explain very quickly a few things. First, black color. Black is a good radiator. Okay, metal is a good conductor. Then you can see that on this thing, there are a lot of fins. Okay, the fins have a increased surface area. So it actually allow good conduction. Okay, so far? Does it make sense to you? Okay, so I'll just move on quickly. So the three things I need to mention is the black, metal, and the fin. Okay, let's do this question. Question number 5. Okay, do you need to explain the difference between heat capacity and specific heat capacity? The key word here is specific. So can you see specific, there is a kilogram. Whereas for heat capacity, there's no kilogram. So are you clear what's the difference? Do you need me to explain this question? Okay, you think say no need. Bei Kwan, you need me to explain this question? Okay, no need lah. So basically, specific heat capacity is a fixed value or a constant value for a material. Okay, because it is the same value for every material. Whereas for heat capacity, it depends on whatever is there. If it's 1 kg of water, this is basically for the 1 kg of the cup. If it's 2 kg of the cup, it's basically for the 2 kg of the cup. Okay, so now I want everybody, both of you, to do question number B. You start doing B. Pei Kwan, what's your answer? Okay, Yu Ting, well done. Yu Ting, well done. Pei Kwan, do you need help? Incorrect, Pei Kwan. Try again. Let me give you a clue. So for the cup, the mass is the cup. Okay, you don't need to know about the mass. Okay, sorry. This is the formula for the cup. Okay, so you need to know that it is 80 multiplied by 70 degrees Celsius. Okay, then for this, you go and do the same thing and then add them together. Okay, Bei Kuan, you think any help here? So 80 times 70, you will need 5600 joule. Therefore, here MC theta, the amount of liquid is 0.2. The C is 4200 and it's 70 degrees. So what's the answer for this? 58,800. Then you add them together, what do you get? Bei Kuan? Okay, very good. Okay, so the answer for this will be 64400 joules. Okay, let's continue. Okay, but Bei Kuan, you understand how to use these two formula? Okay, Bei Kuan, you understand how to use these two formula now? Hello. Okay, let's continue. Okay, let's label 1 and 2. Bei Kuan, can you do A? Then Yuting, can you do B? Okay, both of you do on the screen. Okay, Bei Kuan, you do A. Yuting, you do B. Bei Kuan, your angle of refraction is wrong. Okay, Bei Kwan, your, hold on, why like that? Okay, Bei Kwan, your this error is wrong, okay, your, okay, angle of okay, all the angles, right, it should be to the, okay, it should be to the, how do you call that? Okay, all your angle, okay, it should always be to the normal. Okay, so this is your normal. This dotted line is your normal. Okay, whereas your this error is to your surface. Okay, so your error itself, it should be here. It should be here. Okay, is that clear? Okay, let me look at the answer for Yiting. Okay, to calculate the critical angle C. 1 over sine C is correct. So your C is, oh, okay. Let me calculate the thing for you. Okay, so the refractive index is 1 over 3. Okay, 1.3. Okay, correct. And okay, for this question, can you see that this is 2SF? Okay, so you leave your answer to 50, it will be better. Okay, but if you are talking about your E max and your A max, right? In your max itself, all your angles are to 1 dp, not 3SF. Okay, all your max question, your answer should be to 3SF. Your angles are supposed to be to 1 dp. Okay, but for physics, you look at the least significant figure. Okay, you understand now? Okay, Bei Kwan, you clear? Okay, everybody understand now? Okay, so part C. Okay, Bei Kwan, you understand why the angle here? Okay, your refracted angle should be here. Okay, it's always to the normal. All your angle is always to your normal. Okay, let's do part C. Okay, so why did total internal reflection now occur at the top surface? Okay, Yuting, well done. Okay, so basically, if this block has increased to a bigger, okay, a bigger refractive index, okay, what happened next? Okay, so what happened is it will bend more, okay? Down here, it will actually bend more. Okay, Yuting, your word should be refracted, not reflected. Okay, so this angle here now is bigger. Okay, it's bigger, and therefore the chance of it having a total internal reflection will be higher. Is that clear? Okay, so number one, at the B, your I has increased. Okay, your I has increased. Okay, when your I has increased, the chance of it bigger than the critical angle is higher. Number two, when your refractive index is bigger, your critical angle is also bigger. Sorry, the critical angle will be reduced. Okay, so these two reasons will make sure that the light that is that actually reaches the new B will tend to be totally internal reflected much better. Clear so far? Okay, let's continue. Bei Kuan, are you okay or not? Because you have not been, you're much less participative today compared to last week. Last week you're very good. Okay, this question is do you all want me to go through? Do you want me to go through this question? Can you type in the chat yes or no? You think say no need. Bei Kuan, do you need me to go through this question on static electricity? Okay, let's continue. Let's see any calculation question. Okay, do you all want me to go through this question as well? Okay, Yuting want me to go through part B. State what is meant by the north pole of a bar magnet. A bar magnet has a north pole and a south pole. Okay, a substance itself cannot be a north pole by itself. Every magnet always have two poles. Is that clear? Every magnet always have two poles. Okay, so what is meant by the north pole of a bar magnet? Okay, so basically, the north pole of bar magnet means that if first of all, okay, the north pole of bar magnet will always points to the Earth north pole. Okay, that's number one. Okay, number two, okay, it will always repel the north pole of another bar magnet and attract the south pole of another bar magnet. Understand? Okay, let's continue. Okay, this one is also another descriptive question. We'll skip this. Okay, let's do this question. Okay, let's do question 10, part A. Calculate the total power supplied to the two circuit by the 230-volt mains when the TV is in full use. Okay, let's start doing now. Bei Kwan, incorrect, because this is milliampere. Okay, try again. Yiting, can you calculate one more time? And why are you in 3SF? Okay, so when the TV is full use, the switch will be closed. Okay, so the current here is 450 milliampere. And when the switch is closed, this is 34 milliampere. So can you find the total power? Okay, Bei Kwan, well done. But can you rearrange to 2SF? Yi Ting is still incorrect. Okay, so basically the power by this power is VI, which is 230 times 0.45. Okay, the power by this is 230 times 0.034. So I add them together. Okay, Yu Ting, can you try again? Okay, Yu Ting, you got the correct answer now. But you look at your previous answer, is all 10 watt. 10 watt and 11 watt. Do you see your mistake or not? Okay, so it's 110 watt to 2SF. Okay, Yu Ting, you understand what's your error here? You go and see your answer. Oh, okay, okay. I know why I see wrongly. Because the one okay, I see wrongly because the one, the hundreds, the one in the hundred is in the previous line. Okay, so the answer will be 110 watt to 2SF. Okay, well done to both of you. Let's continue. Okay, let me write down the okay, let me write down here. So there is 450, 34 and 034. This is close. This is open. This is TV. This is standby. Okay. They calculate the amount energy supplied in 1 week by the main supply to the television when in standby mode. Okay, let's do that now. Calculate the amount of energy supplied in 1 week by the main supply when it is in standby mode. Okay, standby mode is when the switch is open. Okay, so when the TV is in standby mode, the switch S is open. Clear? Okay, so in this question, you are looking at when switch S is open. Okay, start doing now. Okay, the voltage is 230 volt. Okay, start doing. Beiguan incorrect. Yu Ting, the whole 1 week, no? For the whole of 1 week. Beiguan, how you get your answer? Incorrect. Try again. Okay, Yu Ting, well done. Beiguan, you need any help? Okay, basically, you know that power is VI. Okay, energy is power times time, which is VIT. And T must be in seconds. Okay, so can you try again? So the V is 230, the I is 0.034. So this means that the on standby mode, okay, the power is actually using 7.82 watts. Okay, 7.82 watts, meaning that every second is actually using up 7.82 joule of energy every second. Okay, then you go and calculate in 1 week, there are how many seconds? Okay, 1 week, how many seconds? Okay, there are 604,800 seconds. Okay, then you multiply these two values together, what do you get? Okay, you should get 42, sorry. Okay, Beiguan, you go and try. So from here, can you find your energy? You know that the time is 604,800 seconds. You know that the PT, the P is 7.82 watts. So what's the total amount of energy being used? Okay, Beiguan, try again. Okay, Yu Ting, try part 2. Okay, well done. Okay, so I'll give you the full answer without the round off first. So because you're going to use that in the next part. Okay, so you'll use this volt, then you'll get 4.7 times 10 to the power of 6 joule to 2 SF. Okay, everybody do part 2 now. Do part 2. Do part 2. Okay, start doing part 2. What's the cost of energy in part 1? Okay, Yiting, well done. Beiguan, what's your answer? Okay, well done. Okay, very good. Okay, so you can see that it's in 1 kilowatt hour. So energy is in power times time. Okay, so in this case, you must change the power to kilowatt. So in this case, will be 0.00782 kilowatt multiplied by time. In this case, the time must be in hours. So it's 24 hours times 7 days. Okay, so that is the amount of energy used by this. Okay. So you'll get 1.31376 kilowatt hour. So every 1 kilowatt hour is 25 cents. So this amount of kilowatt hour costs how much? Okay, it will cost you 33 cents, okay, to 2 SF. Understand so far? Okay, so both of you are able to do this. Well done. Okay, part C. Okay, so can you all share with me why unplugging the TV save more energy? Okay, so when you unplug the TV or the computer, right? Okay, there will be no current, okay, that is being supplied to the computer or TV at all. Okay, so therefore it will actually save energy. Okay, so suggest one disadvantage on why completely unplugging a computer, okay, is not good. Okay, Yuting answer is correct. Okay, let me share Yuting's answer to both of you. She says that the computer is used to more hours. So it may be more inconvenient to have to plug and unplug the computer repeatedly, which is correct. Another reason that you can actually say is that by unplugging the computer, and every time you need to use a computer, it takes time to load. So it actually takes a bit of time before you can start using the computer. Is that okay? Okay, so yeah. Any question for me? Okay, let's continue the next page. Okay, so this is the description question. Okay, do you want me to go through this question? Or just skip You want me to go through this question? Okay, let's continue. Okay, let's do the calculation. Okay, so draw the circuit. Okay, let's do the draw. Okay, so using the figure, the current in the circuit is 40 milliampere. Okay, 40 milliampere. Calculate the output and the total resistance in series. Okay, let's look at this. The I is 40 milliampere. So you're supposed to calculate number one, the voltage of the power supply. And number two, the total resistance of the LED and the lamp in series. Okay, so everybody start doing now. Okay, you think well done. Well done. Okay, because they are both in series. Okay, so can you see LED? For the LED and the lamp, when your current is 40 milliampere, they both have the same potential difference. So what is the value that you see here? Can both of you see? Okay, well done. Okay, so can you all see? Down here, it is 3.5 volt. Okay, so you have the LED and the lamp. Okay, let's say this LED and this is the lamp. Okay, so for this, you put the voltmeter here is 3.5 volt. You put another voltmeter here is also 3.5 volt. So what will be the power supply? Okay, the power supply, you add them together, you will get 7.0 volt. Okay, Pei Kwan, are you clear about this? Okay, so the total resistance is equal to V over I. Okay, V over I. The total voltage is 7.0 volt. The current is 0.040 ampere. Okay, so from here, you use your calculator. Are you able to get the answer? 7 divided by 0.04, you'll get 175 ohm. Is that clear, everybody? Okay, well done, Yuting. I think you are mostly prepared for exam ready. Pei Kwan, I'm still concerned. Okay, so I will just skip the rest of the question now, unless you want me to go through. Okay, I will skip this question unless you want me to go through. Okay, let's do part B. The time base is set as 2 milliseconds per division. So find the frequency. So look at this. So you set it at 2 milliseconds. So what you find the frequency of this? Okay, can you all find that now? Okay, can both of you do this question? What is the frequency of this? Okay, well done, Yuting. Pei Kwan, do you need help for this question? Okay, So can you see this diagram here? Can I say that this is one period? So the period is actually 2 division. Okay, 2 division is 2 times 2 milliseconds, which is 4 milliseconds. Okay, so the time taken for one wave is 4 milliseconds. Then, can you find the frequency? Frequency is 1 over period. Okay, Beiguan, can you try now? Incorrect, yeah. You must change this to seconds. So this will be 0.004 seconds. Try again. Okay, what's the unit, Beiguan? Beiguan, what's your unit? Hello, Beiguan, what's your answer? 250 hertz. Okay, you need to know that the unit is hertz. Okay, let's continue. Okay, I will skip the rest unless you want me to explain. Okay, last question for today. Can you all calculate the pressure of the bubble at the 30 meter? Okay, start doing now. This one shouldn't be hard. Okay, Yuting, well done. Beiguan. Okay, so I will just do part 2 for you all. So at 0 meter, it is 100. Okay, 30 meters. So every 10 meters, it actually goes up by 100, 100, 100. Okay, so how does the graph looks like? It looks like this. Okay, Beiguan, what's your answer for part A1? If you need help, let me know. Okay, so at the surface of this, you will have a pressure of 100 kilopascal. Okay, and this amount of water acting at this point, this amount of water acting at this point is called H rho G. Your H is 30, your rho is 1000, and your G is 10. Okay, so you'll get 300 kilopascal. So can you see? Every 10 meters of water, you just need to sink 10 meters of water inside the sea. Your body will be subjected to twice the atmospheric pressure. Can you understand that? So can you imagine every 10 meters of water above you is equivalent to you are standing at the surface of the earth. Okay, so 30-meter deep, you'll be 3 times the pressure of your atmospheric pressure. So you add these two together. Okay, your answer will be 400 kilopascal. Okay, so you are actually under, when you are 30 meters below the water itself, okay, your body will be under immense pressure of 400 kilopascal against your body, which is 4 times as much pressure compared to at the sea level. So can you imagine our ocean can be as deep as 9 kilometers deep. Just 30 meters, you're already subjected to 4 times the pressure of the sea level. Imagine you go down 1 kilometer deep, you'll be crushed by the water. Is that clear? Can you imagine how much pressure is acting on you just by you just 1 kilometer into the sea? Yeah, and you know that the sea can be as deep as 7-8 kilometers in the deepest part of the ocean on Earth. Okay, is it amazing? Okay, Pei Kwan, you understand how to do this question now? Can you give me some reaction? Hello? Pei Kwan, are you there? Okay, any question for me? Okay, the rest are all calculation question. I will not go through with you already, unless you want me to go through. Okay, if not, I will just end the lesson here, unless you want me to go through any of these questions. Okay, you have no question for me. Okay, you may go. If you have question for me, you may stay and ask me. Okay, thank you, everybody. I'll see you all next week. Okay, bye, Yuting. All the best to your humans paper tomorrow. Bye, Pei Kwan. Okay, good night. Take care. Bye-bye.